Basic Agricultural Chemistry. Grade 11. Aim of lesson. You should be able to do the following at the end of the lesson. Terms: matter, atom, molecule, periodic table and isotopes. Differences between elements, compounds and mixtures, with appropriate examples. Basic interpretation of the periodic table of elements. Differences between acids and bases. General structure of an atom. Main particles of an atom and their respective charges. Relationship between atomic number and the number of particles in the atomic nucleus. Ion formation. Arrangement of electrons around the atomic nucleus and valence. Introduction. Content previously covered in grades 8 and 9 natural sciences must be linked to the current content. The purpose of the following lesson is to discuss the content related to basic agricultural chemistry. Concepts and skills. Basic agricultural chemistry. What is chemistry? What do maize, meat, milk, fruit and sugar have in common? These are all agricultural products, but each substance is completely different from the others. They have different chemical compositions. Chemistry is a natural science and knowledge of basic. Chemistry is important if we want to understand the processes and products that agricultural science deals with. This unit will introduce you to basic chemistry, especially the way it relates to agricultural science. Important terminology. Matter is anything that takes up or occupies space. It has volume, it takes up space, and mass, it weighs something. Atoms are the smallest particles of matter and cannot be broken down further by chemical processes. An atom can be split with a nuclear reaction. A molecule is a group of two or more atoms joined together to form a compound that acts differently from the original atoms. An element is basically an atom of a specific substance and cannot be broken down by chemical processes. Compounds are substances formed by the combination of two or more different chemical elements. The periodic table is a table of all the known chemical elements arranged according to their atomic numbers. Isotopes is one of two or more forms of the same element that contain equal numbers of protons but different numbers of neutrons in the nucleus of their atoms. Protons, electrons and neutrons are all subatomic particles. Neutrons have mass, but are not charged negatively, like electrons, or positively, like protons. Elements appears on the periodic table. Different elements, atoms, are defined by the number of protons they possess. Molecule. The atoms of the various elements are held together by chemical bonds that cannot be easily broken. The smallest unit is a molecule. Connections. In some cases, different elements react with each other when mixed and form bonds between the atoms, producing molecules of a compound. E.g. NO, nitric oxide, H2O, water, NO2, nitrogen dioxide, CO2, carbon dioxide. Mixtures. A mixture is two or more substances that are combined in such a way that each substance retains its own chemical identity. Salt dissolved in hot water is a mixture, which still tastes salty, not a compound. If the water evaporates, the salt will remain. Chemistry is about complex interactions. The differences between elements, compounds and mixtures. Different elements, atoms, are defined by the number of protons they contain. Look for some common elements on the periodic table, e.g. oxygen, O2, carbon Ec and hydrogen, H2. The atoms of different elements are held together by chemical compounds that do not break easily. The smallest unit is a molecule. Water, H2O, and quartz, SiO2, are common compounds. A compound is different from a mixture, where compounds between the atoms that make up the substance do not occur. A mixture is two or more substances that are combined in such a way that each substance retains its own chemical identity, e.g. salt that dissolves in water is a mixture, which still tastes salty, it is not a compound. If the water evaporates, the salt will remain. When elements are mixed, the reaction sometimes takes place very slowly. For example, where iron is exposed to oxygen. In other cases, reactions take place quickly, for example when lithium is exposed to oxygen. A compound often looks very different from the elements of which it is composed and acts differently. The elements, molecules, and compounds in mixtures are not chemically bonded. Mixtures can be separated by physical methods. Biotic and abiotic matter. As agricultural scientists, it is also important for us to know that the environment consists of things that live, biotic, and things that do not live, abiotic. Important abiotic substances include water, rocks, sand, and air. Biotics include all plants and animals. Some substances do not fit neatly into the definition of biotic or abiotic. Land is a good example of this. It consists of a living as well as a non-living component. Properties of the periodic table. See periodic table attached here too. The periodic table is like a big grid. Organized, with rows running from left to right and columns running from top to bottom. Each element is placed on the grid in a specific place due to the way it acts. It has to do with its chemical properties. Each row is a different period. Elements in the same row have something in common. It all has the same number of atomic orbitals. Each element in the top row, the first period, has one orbital for its electrons. All the elements in the second row, the second period, have two orbitals for the electrons, and so on. The maximum number of electron orbitals or shells for any element is 7. Each column, running from top to bottom, is called a group. The elements in a group have the same number of electrons in their outer orbital. Each element in the first column, group 1, has one electron in its outer orbital or shell. Each element in the second column, group 2, has 2 electrons in the outer shell, and so on. Hydrogen H and helium He are the exceptions. Hydrogen sometimes needs an electron, and sometimes it has an extra one. Helium is different from all the other elements. It can only have electrons in the outer shell. Although it has only 2, it is still grouped together with elements that have 8 noble gases. The elements in the middle part of the periodic table are called transition elements and have special electron rules. The differences between acids and bases. Atoms or molecules are sometimes positively or negatively charged. It is a state of electrical imbalance, and nature will try to cancel it out. Atoms with a charge are called ions. Ah+. Ion is a hydrogen atom with a positive charge. Liquids are acidic or alkaline, and this has to do with the presence or absence of H+ ions. The table shows the most important differences between an acid and a base. Acid-base. Tastes sour and has a strong smell or feeling slippery or soapy. Gives off hydrogen ions, take up hydrogen ions. Has a pH of 0 to 6/low, has a pH of 8 to 14, high. Examples are HCl, lemon juice, citric acid, vinegar, ethanoic acid. Examples are sodium hydroxide, calcium oxide, lime, ammonia. Acids and bases. Acids. Acids are an important group of chemicals. It is important in agriculture to know whether soil is acidic or not, because certain plants grow better in acidic soil. Potatoes, sweet potatoes, beans and cabbage are crops that grow well in acidic soils. What is an acid? All acids contain hydrogen. When an acid mixes with water, it becomes reactive and gives off hydrogen ions. Acids, which are dissolved in a lot of water, are called dilute acids. Acids, which are dissolved in a small amount of water, are concentrated acids. Acids that release a lot of hydrogen ions quickly are called strong acids. Weak acids release less hydrogen ions more slowly. When acids react and lose hydrogen ions, they form salts. The following are the main types of reactions of acids, each with an example. Acid plus metal salt plus hydrogen. Hydrochloric acid plus sodium chloride plus hydrogen. Acid plus base salt plus water. Hydrochloric acid plus sodium hydroxide, sodium chloride plus water. Acid plus carbonate, carbon dioxide plus water plus salt. Hydrochloric acid plus calcium carbonate, calcium chloride plus carbon dioxide plus water. Bases. Bases are the chemical opposites of acids. They react strongly with acids and can neutralize acids or cancel their effect. This happens because bases accept hydrogen ions from acids during chemical reactions. Most crops grow best in slightly acidic soils. If soil is too acidic, a farmer can add a base such as lime, calcium oxide, to make the soil less acidic. Bases that dissolve in water are called alkalis. Crops such as parsley and peppers grow in slightly alkaline soils. The pH scale. The pH scale describes how acidic or alkaline a liquid is. Although there can be many types of ions in a solution, pH focuses on concentrations of hydrogen ions, H+, and hydroxide ions, OH. The values of the scale lie between numbers very close to 0 and 14. The pH of distilled, pure, water is 7. The pH of acids is between a number very close to 0 and 7. Bases pH is between 7 and 14. The general structure of an atom. An atom is a substance in its simplest form, and cannot be further decomposed in a chemistry laboratory. Atoms are made up of even smaller particles, called protons, neutrons, and electrons. If an atom is so small that you cannot see it under a microscope, just think how small these subatomic particles must be. Particles of an atom and their charges. Proton has a positive charge, plus. Electron has a negative charge. Neutrons have no electric charge. Not all atoms have the same number of protons and electrons. Atoms that have the same number of protons and electrons are called elements. 92 elements are found in nature. Each element is represented by an abbreviation, or symbol. These symbols consist of 1 or 2 letters and are shown on the periodic table. Relationship between atomic numbers and the number of particles in the nucleus. Each element has a name. The simplest element is hydrogen. Hydrogen's atomic number is 1. This means that there is only one proton in the middle, or nucleus, of a hydrogen atom. To balance the positive charge of the proton, the hydrogen atom has a single, negatively charged electron in it that you can consider as an orbit around the nucleus. Neutrons are found along with protons in the nucleus of the atom. Because they have mass, they have an influence on the total mass of the atom. An element's atomic mass is approximately equal to the total number of protons and neutrons in the nucleus of one atom of that particular element. The formation of ions. An atom with one or more extra electrons, or one or more missing electrons, is called an ion. Ions that have gained electrons are called anions and are negatively charged. Ions that lack one or more electrons are called cations and are positively plus charged. Ions with opposite charges attract each other, while ions with the same charge repel each other. A chemical bond occurs when an anion and a cation together form a compound. Arrangement of electrons around the nucleus and valence. Most atoms have several protons. To balance the charge, they also have several electrons. The electrons are found in orbits or orbitals as follows: lane 1 maximum 2, lane 2 maximum 8, lane 3 maximum 18. The electrons in the outer orbit are called the valence electrons. It is they who are usually involved in a chemical bond. The orbits closest to the core have the least energy and the furthest, most energy. When molecules or compounds are formed, atoms share electrons from the outer energy level. Activity/assessment. Do revision exercises at the end of the lesson in the textbook. Consolidation. The lesson covered the content set out in the CAPS document. Values. Learners who understand the content must use the knowledge and skills to successfully answer questions based on the curriculum content.
Please like, share, and subscribe to the channel for more future educational videos.